So this lecture is the second lecture to introduce the ecological approach to cognition. We talked about evolution in the last lecture as one of the pieces that contributes to the ecological approach, and now we're going to have a final introduction to cognitive theory and how the cognitive revolution and studying animal cognition helps us with this ecological approach to cognition, where we combine evolution and cognitive theory. So for this lecture, chapter 1 in the Genius of Dogs will be most helpful. And of course, anything about cognition is designed using the ecological approach to cognition, so you can see it in action. Chapter 3 in the Genius of Dogs is sort of a first example where this is the ecological approach is used, so you can see how we went experiment by experiment deploying this approach. Okay, so we talked about what cognition is already. Cognition is the mind flexibly solving problems. It relies on internal mental processes. That's why we need experiments. But it allows for inferential reasoning, leading to flexible problem solving. And of course, there are many types of intelligence that often vary independently. So that's very important when you're thinking about cognition as an explanation to intelligent behavior. But an ecological approach to cognition builds on that and emphasizes the importance of flexible behavior. Basically, without flexible behavior, there is no cognition and there isn't something to recognize as potential cognitive adaptation, something that actually is allowing the animal to survive and reproduce better in the ecology or in the environment that you find it in, which of course is then reflecting back to when we were talking about evolution, is what's the payoff for any trait. And with flexible behavior, you can have payoff from cognition because you will be more successful at solving new problems and being flexible, and potentially being more successful at reproducing and having the genes or the heritable component of your cognition pass on to future generations. But what is flexible behavior? Well, that's actually the most important thing to define. And of course, the Swiss Army knife is there because that's really how a lot of people think about cognition and also about flexibility. Is there's different types of cognition, different types of intelligence, and just like a Swiss Army has different tools, different species have different tools they deploy to solve different problems. But here's how we think about flexible behavior. If you really pushed me and made me define it, flexible behavior requires a goal that you are trying to acquire food or a mate, or you want to climb a tree, etc. And there's a decision between different actions or means to reach your goal. I could take this path, or I could take that path. I could climb that tree, or I could go dig a hole under the tree. And that decision has to be made to potentially accomplish your goal. And complexity is created when there are sub-goals that must be reached before the larger goal. So I want to open a can of canned food, but to open the canned food, I first have to get a ladder because the knife that I need or the can opener I need is really high up in the cabinet. So I've got to go get the ladder, then I've got to open the cabinet, get the can opener, and finally, after I finish those sub-goals, I will be able to complete my final goal of getting food. So complexity is created when sub-goals must be reached before a larger goal. So the tricky thing about flexibility, though, is that when you see complicated things, you may think that complexity is a good definition of flexibility, but it's dangerous because there are lots of animals that have complex behaviors that aren't particularly flexible. So complexity is really not sufficient alone as a criteria for cognition. And that's again because there are innate behaviors that many animals express that can be very complex. Think about termites building termite mounds, or the different ants that have so many complicated behaviors, but they're not particularly flexible. So thinking about inflexible behavior actually and defining what is not cognitive helps us think about what is cognitive, and think about the example of insects that have a hard time with human lighting. Of course, moths and other animals didn't evolve to deal with human-made lighting, and they're using lights from the star, from the moon, to navigate at night. But when we have all these artificial lights, it really it really hijacks their mechanism for navigation. They're attracted to these stimuli, and they do things that seem really maladaptive and relatively unintelligent, which is they fly into candles and kill themselves. Or they bump into our lights all night long, and obviously that's energy that could be used to forage. So another example would be an ant mill. This may be something you're less familiar with, where ants that use pheromones to navigate, and they, as they're walking, they're dropping pheromones, and that's a signal to anybody to follow that's in their group. And as they're dropping the pheromones, though, what happens sometimes, especially in South America, with certain species of ants, where there's a heavy rain, is they get disturbed and they start going in one set of ants starts going in a circle, and starts dropping pheromones in a circle. But then everybody starts to drop pheromones in a circle, following them in that original circle, and you end up with a massive entire group of thousands and thousands of ants going in a giant circle over and over and over in what's called an ant mill. There is a link to a YouTube video if you want to watch an ant mill. Because it is something to see. And so these are two examples of inflexible behavior that help us think about what is not cognitive, which then of course helps us think about what is cognitive. And flexibility is really rated on a continuum. It's relative. There's really no absolute dividing line between behavior that's flexible that then allows it to be considered cognitive. And that's really one of the challenges. And then when behavior shows inflexibility, it's clear that there's likely some programming that's occurred into whatever organisms we're thinking about, into their nervous system in anticipation of some invariant environmental situation. Think about the moths navigating with the moon. I mean, human artificial lighting is just a little over or just 100 years old. And so moths, of course, have been around for millions of years, and using the moon or stars to navigate, of course, is a very good strategy until very recently. So that's a case of inflexibility.